Or I suppose, how would you show it doing, how would you do part A?
Would you use long algebraic division?
And what would show that it's a factor?
The remainder.
What would the remainder be?
0.
Yeah. And so, how would you show it using the factor theorem? Because I don't feel like spending lots of time doing long division when I already know the answer is going to be 0. Or the remainder will be 0. Is there a quicker way to find the remainder?
Yes. But I forgot.
X minus 2. So it would be, if we were to factorize this cubic, you get like 3 brackets. If x minus 2 is a factor, then that's one of the factors.
Yeah.
If it, when you're solving it and you'd say like x minus 2 equals 0 or ... x minus 2 equals 0, solve for x.
So x is 2.
X is 2. Sub that in. 2 cubed plus 2 squared minus 4 times 2 minus 4. What will you get?
You'll get so minus 4 multiplied by the 2 in the brackets is just 8, right?
Yeah, but you could just put it all in the calculator or whatever you like, I suppose.
16.
So you'll get 8 plus 4 minus 8 minus 4.
It'd be minus 8. I thought it'd be plus 8.
Minus 4 times positive 2. Difference.
Oh. Okay. It's not 4 times 4 then. Not 4. Yeah. It's not 4 times minus 2. It's okay.
Yeah. X was equal to positive 2.
Yeah. So is it 0?
It's 0. And that's what we were expecting to get. And it's a show that question. Last thing you say.
So therefore, x minus 2 is a factor of x cubed plus x squared minus 4 or x minus 4.
Yeah. And I'm just going to write x minus 2 as a factor. They know what it's a factor of. Yes. What would you get? You see this bracket up here?
Yeah.
What would you get if you subbed 2 into that?
What do you mean sub to 2?
For x.
0.
Yep. You would get 0 times something, and it would be 0. Anything times 0 is 0. And that's why if you sub in one of the solutions and you get 0, then that verifies that it's a solution. Verifies that x minus 2 must be a factor. Yeah, a remainder of 0 shows you that it's a factor. 1 second. Ooh, this is interesting. I'll come back to that. How would we do part A?
Well, we know x is minus 4, right?
Yep.
So do we sub it into 9x cubed plus 24x squared minus 44x plus 16?
And so you show you're working out by subbing it in.
Yeah.
Like that.
Yeah.
What answer will you get?
How come for plus 24 it's minus 2?
Because I'm a silly man. I did it again. Minus 4. Predict.
And you get 0.
Yep.
So then would you write out therefore, x plus 4 is a factor of fx?
Yeah, I like that. Of the f of x. Great. You got the idea. Oh. Right, how about this thing?
Okay. So x is -1.
Yep.
So for this, it's, what would you call it? Because it's to the power of 4.
Quartic.
So for the quartic graph, it doesn't state a cubic number, or it doesn't state a cubic number. So would you put 0 for it?
Sure. Hold the phone though. You don't need to worry about any of that.
Okay.
What's next?
You sub in -1.
Sub in -1.
Then could you solve it in the calculator?
You stop with your calculator. I suppose you could. How would you solve it in your calculator?
Would you put a as x? Would that
Yeah.
not work? You could.
It has to be equal to something though.
0 always equals to 0.
Yeah, that would be equal to 0.
X is -1, that's what it says.
Yep. A equals -1.
Yeah.
And I did it manually. 4 times -1 to the 4 is 4. -3 times -1 squared is -3. 4 minus 3 is 1. 1 plus 8 is 0. A is -1. Here we go. Good. Let me see if there's any more exam questions like that. My guess is they won't even bother. Oh, they will. Okay, this one.
Okay. So x is -1 again.
Yeah.
So it'd be written out as -1 cubed plus 2 brackets -1 squared -19 brackets -1 plus k equals 0.
Mm-hmm. And this is a show that question. So I would just put into your calculator everything without the plus k equals 0. So just
Okay.
-1 cubed plus 2 times -1 squared -19 times -1.
Okay. Would it still be equal to 0 though, right?
Like I would just get the numerical value.
Okay. I got 20.
So we have 20 plus k is equal to 0.
So k is equal to -20.
K is equal to -20. See, this is a show that k is equal to -20, and so it's not always obvious how much detail they want you to go into, and so just to be safe, we'll do that, and we've shown it. Okay, let me see. Okay, let me now go back. So what's this factorizing malarkey all about? How would we do this?
For question A, would you just put that into calculator?
Yep.
Okay. So x1, would you put it in brackets? Brackets.
You can do x1 equals.
Okay, so x equals 3, x equals minus a half, and that's all.
Press equals one more.
Oh, sorry, minus 3.
X equals minus 3. Okay.
So it would be brackets x minus 3. And then would this one be 2x is 1.
So 2x would be equal to minus 1. And so bracket.
Plus 1. And the last one would be x plus 3.
Okay, part B, hence sketch the graph. How do we do that?
Okay.
And hence means using your previous answer.
Okay. Well, we know what x is, so we just substitute x back in.
Nope. For these solutions, essentially it's equal to 0. Y is equal to 0.
Yeah.
Let me write it a different way. 0 equals that. And so we have the three solutions. So when y is 0, it's on the x-axis, like the y-coordinate is 0.
Yeah.
So 1 is 3. What else?
X is minus a half, so that'd be on the left.
Yeah.
And the last one would be minus 3, all the way on the left.
Minus 3. Y-intercept is when x is 0. So when x is 0, what is the y? What is y equal to?
So would you just substitute 0 in for all the x's?
Yep. What would you get?
You'd get 0.
You'd get 0 plus 0 minus 0 minus 9.
So you'd get minus 9.
Yeah, so y equals minus 9. So when x is 0, y is minus 9. That's going to be down there. And when y is 0, x is 3 or minus a half.
Yeah.
And then we sketch the graph. It's a positive cubic. Any idea what that's going to look like?
We'll start from the bottom left.
Yeah. That's the best I can do. That's my little sketch.
Okay.
And that's what it looks like. Great. Any questions with that one?
No.
Okay. Oh, what happened? There we go. Find all the solutions. See. Yes. Let's try part B and C.
Okay. So could you just sub x cubed plus 2x squared minus 19x plus minus 20 into the calculator?
Yeah.
Okay. So x is 4, x is minus 1, and x is 5.
Okay.
Should be written out as brackets x minus 4, brackets x plus 1, brackets x plus 5.
Okay. And hence part C.
Okay. So we know the x points, so we plot them on the x-axis. So when x is a value, y is 0.
Yep.
So the first one will be 4,
Yep.
all on the right of the graph.
Yep.
The next one would be minus 1, and the next one would be minus 5.
Minus 5. Okay.
And then you substitute 0 back into the equation.
Yep.
And then you work it out. So it'd be, so the y-axis is minus 20.
Yep.
And then you draw out the graph. Is it? It's a positive graph.
Yeah. And you previously told me that that starts bottom left. Wait. And you can also put it into your graphical calculator.
Yeah.
Let me just give this a go. It's, like here you can see they really structured it so it's like so you wouldn't use a graphical, but let's see. I have to go back to normal type. I was doing some other stuff. Delete. Yes. Hopefully that's okay. So x power of 3 plus 2x squared minus 19x minus 20, and there we go. Shift view window initial. Ooh, that's worse. Shift zoom auto. Hey, that's not bad. Yeah, grand. And so you can get it that way. Let me copy that, paste it, see if that. Hey, there we go. Cool.
Yeah.
And we can see, yeah, it crosses at minus 5, minus 1, 4. And if you were really stuck, you could say shift. Is it shift or option? No, I thought it was shift. Shift, yeah. Shift graphical solve, G-solve, y-intercept, and it says it's minus 20.
Yeah.
Great. Any questions there?
Nope.
Yeah, you're good for these. Hang on a second. Hence show that there are exactly 2 real roots for this equation. Yeah, because it'll be a square bracket, I think. It'll be one repeated root. Yeah. One would be x equals minus 3. The other would be x equals 5 over 2, because that shows up twice. Because it's squared. 4 is the only real root. Ooh, there might be a trick to this one. Yeah, I think there is. It says x minus 4 as a factor. What happens when you try to factorize this one?
Would you only get x equals 4?
So yeah, you'd only have one bracket of x minus 4.
Yeah.
Let me just quickly show you. They really know what they're doing, I have to say, with these questions. Sorry, we want cubic 3 minus 12 6 minus 24. So that's a 4 one. And then our other answer, imaginary number.
Yeah.
Negative imaginary number. Let me see. So we have to how would we show that that's the only root? So they can't see our calculator.
Would you substitute minus? Would you substitute 4 in for x?
You would get 0. Therefore, x minus 4 is a factor.
Yeah.
Essentially, we know if so the f of x. We know if x minus 4 is one of the factors.
Yeah.
That's like one of the brackets.
Yeah.
And so what would be the other bracket?
3x cubed minus 12x squared plus 6x minus 24.
Hold on. X times what gives you 3x cubed?
Oh, 3x squared.
Yeah. What would be the number at the end?
6.
So that would be plus 6. And then we just need to figure out the middle bit. We could say plus bx. And then we could expand just the something just to compare.
Yeah.
So let's expand out let's expand out the squared things. So what is x times bx?
Bx squared.
And what else will give us an x squared when we expand it out?
Nothing. Would there be one more?
So we could fully expand all 6. These two will give us an x squared.
Oh, yeah. Yeah. So do we minus 12x squared?
Minus 12x squared. And that has to be equal to has to end up giving us minus 12x squared. Is that right?
Yeah.
Yeah, okay. So what is b then?
So to work this out, would you just minus plus 12x on both sides?
Yeah, what do you get?
0.
So is b 0? So what is the other bracket then?
3x squared plus 6.
I think so. Yep. How would you show that this one can't be a root? That there's no real roots for this other one?
Would you expand the brackets?
You would try to solve them.
Okay.
So we know the first one is x equals 4. Try solving the second one.
Okay. So can you just put that into the calculator?
You'll get the two imaginary numbers that we saw earlier.
Yeah, square root 2i minus square root I. That's what I got.
So try solving it manually.
So you minus 6 on both sides.
Yeah.
Which gives you 3x squared equals 0. No, it's not 0, 6. and then you divide by 3 on both sides. So
Uh,
it gives you,
minus 6, I believe.
oh yeah, minus 6, sorry. So you do divide 3 on both sides.
Yep.
Uh, you get x squared equals minus 2. And then x squared equals minus 2. Then you square root both sides.
What is the square root of minus 2?
Square root minus 2. Math error, because you can't square root a negative number.
Yes. No real roots. And it's a show that question.
So, would you say therefore, 4 is the only real root of the equation fx equals 0?
Yeah. Well done. Okay, so how do we go about this? We have to fully factorize. We can't factorize the other one into 2 brackets, and that's because it doesn't factorize, it doesn't have factors. And so we try to solve it, and we show that it has no real roots, therefore the only root is the other one.
Yeah.
Alright, I think that's okay. It's long though. Let's see. Grand. Let me just make sure. Yeah, I think that's it really. Okay, factor theorem.
Probably a tick. It's pretty easy.
I agree. Okay, proof. How would you go about this one?
Would you just expand the brackets?
Sure would. What's the easiest way to expand triple brackets?
You do the first 2, and then you do the last one.
You do the last 2. And then the first one. And that'll make your life easier.
Yeah.
Ooh, I don't know how this is going to work. Okay, how about this?
So would you substitute 0 into p?
Let's see. Prove that if x minus p is a factor of the f of x, then f of p is equal to 0. If x minus p is a factor, so that would be like x minus p, let's just say f of x. So you have the f of x, which they're saying x minus p would be one of the factors. Solve our little thing here. So if x minus p is a factor, so how do we usually do factor theorem? If p was a number.
Could you do long division?
Quick way?
You could factorize it to get what x is and then substitute x into it.
And so what would be x equal to for this one?
Equals p.
So I think for a kind of prove that, I'll just first write x minus p is equal to 0. So if x minus p is a factor, then x equals p is a solution, is a root, something like that. Therefore, the f of p, maybe I'll just write, yeah, the f of p would be equal to, if I put it into this bracket here, what would it be?
Which bracket?
Up here?
It would be p minus p.
Yeah, p minus p, and then the other bracket I'll just call the g of x. I don't know what that's in there. Go on.
Would be equal to 0.
So that is 0 times the g of x.
Yeah.
Which is equal to 0 And yeah, therefore the f of p is equal to 0.
Yeah.
Hopefully that counts as proof. So I'm just doing all of the steps of the factor theorem, but with a letter instead of a number.
Yeah.
Okay, let's see what they said. Oh, they said something very similar. I can be proud of myself. If x minus p is a factor of the f of x, then the f of x is equal to, x minus p in a bracket times some other g of x.
Yeah.
F of p is equal to p minus p. 0 to that's exactly. Phew, I'm tell you, I hate this proof stuff. Didn't do too bad. Let's see. Prove that. Okay. Prove that. Okay. 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 Prove that. Sure. Oh, it's a lot of okay. It's a lot of stuff. A lot of stuff. Let's see. How would you prove that a triangle is a right-angled triangle?
Okay. Vertices are corners, right?
Yep.
Okay. Can you just plot a graph out?
Could. So 1, 1, 3, 3, 2, 4. All right. Oh, 4, 2. So it looks a bit like that or something.
Yeah.
Okay. How do you prove that that a triangle is right-angled?
One of the angles has to be 90 degrees.
How do you show that one of the angles is 90 degrees?
Just draw a square.
I have some ideas. You could get the gradient of AB and the gradient of BC.
Okay.
What will be gradient of AB?
So we use y equals mx plus c.
Y2 minus Y1 over X2 minus X1.
Okay. So we'd use. So okay. So it'd be 3 minus 1 over 3 minus 1.
Yep.
Which would give you 0, no 1, because they divide.
Yep.
So the gradient of AB is 1.
Yep. What would you do next? We're trying to show it's a right angled triangle.
And then would you work out BC's gradient?
Yep.
Okay. So it'd be 2 minus 3 over 4 minus 3. Which gives you minus 1.
This one. And anything you know about any idea what you do next?
Would you need to make minus 1 positive or something?
essentially we have to show that these gradients are perpendicular. If two gradients are perpendicular, when you multiply them together, you should get -1.
So you do 1 multiplied by -1, which gives you -1.
Yeah, therefore...
So they are perpendicular. Therefore, the triangle ABC is right angled.
Yeah, right angled triangle. Yep. And how would we just... So those two are perpendicular. Yeah, I think I don't know. They wrote a bunch of extra stuff. I thought they might. Let's just see. 1, -1. They did the gradient to the other line. Don't need that. The gradients are different, so the 3 points are not collinear. That means, that the third line isn't parallel to. It's not on the same line.
Yeah.
So hence ABC is a triangle.
Yeah.
Hang on. Hence it's a triangle. Yeah, I suppose they didn't tell us it's a triangle. We had to prove it. The gradients of those two multiply and make -1. So AB is perpendicular and the triangle is right angled. Okay, so we just had to get the gradient of the third side and show that that's different. Therefore, it is a triangle because they're not on the same straight line. Okay. How do we do this?
So we know that K is between either 0 or under 8/2.
Yep. Gotta prove it though. No real roots.
Okay. So do we know it's a negative number?
What do we know about a quadratic that has no real roots?
We know that it doesn't touch the x-axis, doesn't go through the x-axis or touches the x-axis.
Yeah. What would happen if you put it in your calculator to solve it?
It will give you a number and then I.
Yeah. What part? Why is that?
Pardon?
Why is that?
Because
or let me phrase it a bit differently. I'm trying to not give it away. When you put it into the calculator subs it into the quadratic formula.
Yeah.
What part of the quadratic formula determines how many solutions you're going to get?
X.
Nope. You remember the quadratic formula?
Yeah. Oh. It's square root b squared minus 4ac.
Yes. B squared minus 4ac is the bit that will determine how many solutions you get. If there are no real roots, then what do you know about this b squared minus 4ac?
It's lesser than 0.
Yeah, it's a negative number. It is less than 0. Do it to it.
So now can you substitute A, B, and C in?
Yep. And it helps to list them first.
Yeah. So A is just kx.
Just k. K is a number.
Oh yeah. B is 3k.
Mm-hmm.
And C is 2. So it'd be 3k squared minus brackets 4 brackets k brackets 2 is lesser than 0.
Yep.
And then could you multiply minus 4k, which gives you 3k squared minus 4k brackets 2.
Yep.
Then could you multiply minus 4k by 2?
Yep.
Which gives you 3k squared minus 8k
Mm-hmm.
is less than 0.
Yep.
And then would you plus 8k on both sides?
You can do 3k squared, 3k times 3k.
9k squared.
Yep.
It'd be 9k squared minus 8k is less than 0.
And we now need to solve for k. How would you solve for k?
Could you plus 8 on both sides? Plus 8k.
You could. There's two ways to it. Let me give you a bad way first. Calculator.
Okay. I got 0 is less than x. X is less than 8 over 9.
And so that's what we're trying to prove, basically. 0, it's in between 0 and 8 over 9. But let me think here. How do we prove it? Factorize out k. What do you get?
You just get 9k minus 8.
So k, 9k minus 8 is less than 0.
Yeah.
And so from there's a few different ways. You could sketch the graph. So if you were to make it equal to 0 and sketch the graph, it would look like that. When is it less? It's k is less than 0 in between those two. That's when the graph is less than 0. I'm just wondering what method of proof. See, I just don't know how much is necessary. So they sketched the graph to prove that question. Who knows how much is necessary? If at that point you could just put it in the calculator.
Yeah.
I'm not sure. Yeah, basically no real roots. B squared minus 4ac is less than 0. All right.
Yeah.
Any questions there?
Nope.
Let's see. So this one is kind of a different thing. That one you're just expanding. Yeah. All right. How do we do this?
Okay. So would you work out what A, B, and C are first?
Yep.
So is A just 1?
Yeah.
B is K minus 3.
Mm-hmm.
And C is 3 minus 2K.
Mm-hmm.
And then you substitute them into B squared minus 4AC.
Mm-hmm.
Which gives you K minus 3 squared minus brackets 4 brackets 1 brackets 3 minus 2K.
Mm-hmm.
So you can do, okay, so could you multiply 1 by 3 minus 2K, which gives you 3 minus 2K.
Yep.
So then you can do minus 4 brackets 3 minus 2K. And then you could multiply minus 4 by everything in the bracket,
Mm-hmm.
which will give you minus 12, 8K plus 8K. And then it would be K minus 3 brackets squared. Then would you expand K minus 3 squared?
Mm-hmm.
Which would give you, simplified down to K squared minus 6K plus 9.
Mm-hmm.
And then that'd be written out as K squared minus 6K plus 9 minus 12 plus 8K.
Mm-hmm.
Which simplifies down to K squared minus 6K minus 3 plus 8K. And then you can simplify that again. 6, 8. So it can be simplified down to again K squared plus 2K minus 3.
Okay.
Which is, would it be, is less than 0.
Yeah.
And then can you put that into the calculator?
See, if we have to prove it, I'm not sure if we're allowed to do that.
Okay.
Um. Sketch. Factorize it. What would it be?
What? It'll be K brackets K plus 2.
Fully factorize.
K plus 2. Would that be right? And then
let's see. I think it's K plus 3, K minus 1. How would you sketch the graph? Or no, sorry. We would just solve it, but without you solve it as equals. So if you put that in the calculator with equals, what would you get?
Okay. You'd get X is 1 and X is minus 3.
And so how could you sketch the graph?
You'd have a point on X is 1, Y is 0. And another point where X is minus 3 and Y is just still 0.
Yeah.
And then it would be, would it go through the 2 points?
Yeah. Sad face, happy face.
Happy. Wait, no.
Happy,
Yeah.
Indian happy. Where is the graph less than 0?
Less than 0.
Yeah, in terms of k. Where is it below the line?
Between -3 and 1.
And so that proves that b squared minus 4ac is less than 0 between 3 and -1.
Yeah.
So, yeah, I think that step might be necessary. Let me see. Might not be. Who knows? Who knows? But just in case. Okay, just in case.
Yeah.
Because they did it a second ago, they didn't here. Okay, how about this one?
Okay. So would you -4 on both sides?
Yep.
Which would give you x squared plus 8x plus 16 is greater than or equal to 0.
Yeah, hang on. Before we do that, this one's okay. It's very similar. How would you start this one?
Would you work out what A, B, and C are?
So A is P, B is -5, C is -6.
And then substitute them into B squared -4AC is greater than 0.
Well done. That's greater than 0. So you end up getting 25 plus 24p is greater than 0. And then you just solve for p. 24p is greater than -25. P is greater than -25 over 24. Okay, so that's a greater than type where it's two distinct real roots and it wasn't quadratic. There is proof that this line is... Man, there's so much proof. So much proof. Because it's not even that, it's just the type of proof. Now, just have to do it next time because even the next part is proof by exhaustion, so there's just more proof than I can do about it. Let's just see. So okay, so the next one is lots more proof, and then it's the end of this chapter. Alright. So what do you give yourself for that stuff so far?
Probably between 6.5. Yeah,
it's alright. Proof. I'm not a fan because it's never obvious exactly how much you need to say. But anyway.
Yeah.
Yeah. How was that for you, Adam?
That was good.
Any questions for me in general?
No.
Alright, let me just... Hang on. It's because there's so much. Okay, factor theorem. If this is a factor, then that bracket must be equal to 0. And so when you sub in 2, in this case, this bracket would be 0. And so when you multiply them out, you get 0. And so that means if you sub in 2 into the original as well, you would also get 0.
Yeah.
And so you can use that to show it's a factor by showing it has a remainder of 0.
Yeah.
Fully factorize these, that's all right. And then use that to sketch the graph. This one, if it's a factor, then when you sub it in, it's equal to 0, and then use that to solve. Okay.
Yeah.
This one, show it's a factor. Yeah, that's good. Sub it in, solve using the fact that it's a factor. Yeah. How did we show that 4 was the only real root?
We had to multiply it to work out what bx is.
Basically, you have to factorize. So one bracket we know is x minus 4 because they tell us one of the factors is x minus 4. Yeah. So you're saying you multiply it out so you can compare, is it? So you can get the second bracket. Yeah. And once you know what the second bracket is, what do you do?
You have to work out. You have to solve, factorize and solve.
Yeah.
The bracket.
You try to solve the bracket and you show that you can't because you have a negative.
Yeah.
Yeah. That's how you show that there's only one root in that case. Prove. Expand those brackets. So this just proving it is putting it in terms of just pure algebra. Same steps.
Yeah.
How do we prove that something is a right angle triangle?
You have to work out the gradient of 2 of the sides.
And
then you multiply them together. And if you get -1, it means you got to write it's perpendicular.
Yes. Well done. And the third side has a different gradient. Therefore they're not on the same straight line. Let's see. This one, just discriminant. Let it be less than 0 because there's no real roots. That's all right, I think. And then the other one was if it has 2 distinct real roots, discriminant is greater than 0. Yeah, great. And so continues next time?
Yeah.
Any questions from me in general?
Nope.
Okay. Well done, Adam. You did great. And hope you have a nice weekend.
You too.
All right, take care. Goodbye.
You too. Bye.
Bye.